There you go, we're recording. Caden, do you mind turning off my front lights here, please and thank you. I have some highlighters ready to go. And just be open-minded, okay? Maybe today you might not get it 100%, but we'll go through this, okay? We'll do it together. I want to say this before. We're recording, we're live. So this is something that the exam will do as well. It will tell you to not round in this unit. This unit you do not round. So you will see what I mean, because it's all about precision, being as precise, right? Getting down to the very smallest detail, okay? So we're gonna continue here. So just fill in some of the blanks that are gonna come up here. So the first thing we're gonna talk about is accuracy. What is accuracy and how can it be affected? Okay, so accuracy refers to how close a measurement is to its target value. To be accurate, a measured value must be as close to the real value as possible. Okay, can we put on top of target? I will put in brackets what we will refer to at times nominal. Nominal is kind of like what we're aiming for. Okay? So imagine an object. I don't know, I'm going to grab my apple here. I don't know why I'm grabbing an apple, but morning. This is an apple, right? In reality, we know that this measurement exists and it's supposed to be something. Like we know that it has a limited, finite amount. So if I grab a measuring instrument and I try to measure it, okay, accuracy is how close this thing, sorry, it's out of battery, but how close this measurement would be to what it actually should be. Right? There is like this target, and accuracy of this device will depend on how close I get. If I use this thing, to measure, this huge thing to measure that apple, I'm not going to be as accurate because this is intended for longer distances. This will be a bit more accurate, okay? So it's going to be closer to my target. Next. There you go. If you claim to have measured something accurately, someone should be able to repeat the process and get the same value. Okay. So that's important. I'm going to highlight that part. If you want something accurately, you need to be able to repeat it and get the same value. And to achieve it, we must use a standard unit, and use an appropriate scale. A standard unit, appropriate scale. So to be accurate, to achieve accuracy, right? I will say this, to achieve accuracy. And to be honest, this concept, it's rarely math. There's no math around it. It's usually at like a multiple choice or short answer, that kind of thing, to test you on this. What is a standard unit? You're using something that you would worldwide, everybody would know what that is. Centimeters, inches, kilometers, miles, kilograms, milliliters, ounces, feet, teaspoons, tablespoons, like all those are cups. Those are universal measurements. What are non-standard units? You using like your hand span, right? This is a hand span right here, like going from my thumb to my pinky. Using your feet, your arm, your forearm, anything that isn't standard would be a no-no, right? That would absolutely affect your accuracy. And think about it this way. If I measured something with my foot, and then you measured something with your feet, we'd be off, right? I have size 15 shoes, right? So you can all do, right? Like we would all be all over the place. You wouldn't be able to repeat it. So if I measure this classroom and I measure 20 feet of mine, and then you go for it, you're probably going to count, I don't know, 25, 26, right? So we're going to be off. We're going to repeat the process, but you're not going to get the same results. So that's why accuracy is going to be broken if you use non-standard units. Okay? There we go. Accuracy can also be affected by improper or careless use of the measuring device, as well as a damaged or faulty measuring device. So in order to get accuracy, you must have these two. How can you mess that up? You can use it improperly or damaged. You can also say, hey, using non-standard units, that will all affect your accuracy. And how so? Let me give you an example of not using a device properly, okay? I hope this works, because this is brand new. I just bought this all last year. So this is a kitchen scale. You're probably not going to see that, are you? Let me try something here. Oh, it is on 0. I didn't want it to be 0. You know, sometimes the kitchen scale is not cleared, is not taired. Let me try something else. Just be very patient with me, okay, today, because let's hope this one works. Everything is zeroed now. So I was going to use this example. Sometimes when you, oh, there we go. That's a good one. You're about to use your kitchen scale. You can't see that, can you? There. You're about to use your kitchen scale, and look at this one. It says minus 5.6. You need to zero your scale. I don't know if you're familiar with that, right? You need to clear what's on there. And if you don't clear what's on there, it's usually this button called tear, then your measurement is going to be off. That would be an example of a careless use or improper use of your device. Okay? Another example I can think of damaged, I'm going to use this little cup here, this little measuring device for liquids. If this, for example, let's say you put something really hot in here, and it all bends and melts, and it's now off, it's all like warped, this would be considered now, this would result in an inaccurate measurement because it's damaged, right? So those are things you can use to come up with examples. Don't just stick with the ones that are here. So the first example here is when you're baking, you should be leveling off your cup, correct? Morning. This one would be improper, this would be proper, right? So we would say here a little note, not accurate due to improper use, okay? Needs to be leveled off, okay? Oh, I don't know why there's a period, just needs to be leveled off. That's why this is improper. This one is good because you're leveling it off, so you're using it properly. Second example, ruler. This ruler, this one is good. What's wrong with this ruler? I tried my best. Can you see it that it's warped? Okay, so not accurate. Because the ruler is warped / damaged. Okay, so all we're talking here is about how to be accurate and what would result in inaccuracy. So you need to have specific examples. Don't just say, oh, so-and-so didn't use it properly. No, you have to be specific. Okay. All right, keep going. So if all I do today is just talk and you write down, that's what today is all about. I do think we're going to get to some of the math part, but it is what it is, okay? Page 3. Who's that motorcyclist? It's very loud these days. All right. State whether or not each scenario would result in an accurate measurement. Explain, making reference to the unit being used and the scale. So we're going to look at unit and scale. We need what? Standard units, and we need the scale to be appropriate. So let's go through some of these, okay? And I'll let you do a few. Use centimeters to measure someone's height. That's pretty good, right? Yeah. That would be a good scale. So centimeters is a standard unit. Check. And the scale, right? Scale is appropriate. Note, millimeters, it's a little weird to measure someone's height in millimeters, but it would also be appropriate. Would be okay. Kilometers, not okay. Would you agree with that? So just a little note on the side, because sometimes students are like, well, what's a good scale, right? So there you go. So both of these are checked off. So therefore, this is the math way of saying therefore. 3 dots like that. I don't know why, but that's just what it is. Therefore, it is accurate. Remember, someone will be able to repeat that, and because it has standard units and it's a good scale, right, you can repeat that process and get the same measurement, so we consider this accurate. This is basically our final answer. Next, using your forearm to measure the length of a picnic table. Forearm is not a standard unit. Not a standard unit. Let's continue with scale. Technically, this fails already. It's done, like we're done. We don't have to continue, but the scale is appropriate, actually. Like it's not appropriate, sorry. It's not like unheard of to do that, right? Like it's still small enough. A picnic table is small enough. A forearm would actually work in terms of scale. Measuring the distance between two cities with your forearm, probably not a good idea, right? The scale would be off there, but not a standard unit, so it fails here. It does meet the scale criteria, but we would still say not accurate. So I give you full permission. As soon as you notice what is the problem, just give me that as your justification and conclude, make a conclusion, okay? Meter stick to calculate the distance between two cities. What's wrong there?
Meter stick isn't that long.
It's not that long. So the scale is a problem? Yeah, the scale is a problem. What about the unit? Is the unit okay? A meter stick worldwide. Don't be scared now. I won't do anything. A meter stick worldwide is the same, right? A meter is a meter. Okay? So it is actually a standard unit. I just missed the stage where teachers could still hit students. That's why I'm a little bit like I want to stay away from a meter stick. Distance between. So unit is standard. Scale, not appropriate. In fact, let's go, it's too small. Use what? Kilometers or miles instead. Right? So therefore not accurate. And you might disagree. You might say Hey, I'm pretty sure I could pull it off. I could use a meter stick and get it. I could repeat it and get the same every time. Good for you, but for us, we would say it's not accurate. For all intents and purposes, for this unit, that would be considered not accurate. So try D, E, and F. See what you get there. What are your conclusions? So do the same kind of process, and I'll be right back. So here you go. Using a ruler marked in millimeters to measure the width of a textbook. That would be all right. This is standard. Check. Scale is appropriate. Therefore accurate. Okay. Using your stride or step, and right there, it's not standard. Not a standard unit. We could actually say right there, not accurate. Is the scale appropriate? Actually, it turns out yes. Using your feet to measure a volleyball court is not unheard of. Using your feet to measure the distance between two planets, probably not a good idea, right? Okay. Did I tell you about the space-themed birthday party my son asked me for? I didn't plan it. Anyways, use a tablespoon to measure the amount of sugar required for a cake. This is actually a standard unit. Tablespoon is actually a standard unit. Some of you might contend, but cups, teaspoons, tablespoons, all those are in baking. In the baking world, everybody knows what that is, okay? And sugar, right? Sugar for a cake, scale is appropriate. Therefore accurate. Okay. And the last one here. So this is an example that the province could throw at you, okay? So don't overthink it, just remember what you know about accuracy. Mary used a measuring tape to determine the width of a wood piece. It was supposed to be 4 inches wide, yet she recorded 3 7/8. It's a bit less than 4 inches, right? Why might this be? Explain using your knowledge of accuracy. The unit is okay. Unit is okay. Inches to measure the width of a wood piece is fine. What else can affect it? The use, right? Is she using it properly? That's where the problem is. The scale, sorry, I should also say scale is also appropriate. The unit and the scale is good. So we need to criticize Mary on her skills of actually using it, right? On how she used it. So you can say this. Yeah. Improper. We'll pick on improper use. Mary may not have ensured that the tape is straight and flat. Against the wood piece. That could have been it. So in the attempt of measuring, if this is your measuring tape, if you kind of bend it like that, right? It's an extreme example, right? But that would be inaccurate, right? So maybe she, this little lip there, maybe she didn't make sure that it was like nice against it. Maybe it was a little off like that. So you just use your imagination and just come up criticizing the use of that item. That's all. Okay. I'm going to give you another damaged device, maybe. Could it be damaged? Right? Can we pick on that? Yes, we can pick on that too. It could be some of the markings may have been missing, rubbed off, right? So you're just saying, hey, maybe some of the markings, because it's been used so much, were missing, and so she kind of just measured 3 7/8 because she couldn't really tell exactly what it was. I don't know, it's a bit cheesy at times, but just, right? Then you pick on other things that affect your accuracy. So to summarize, accuracy can be affected by the unit, the scale, the use of it, and damages. I don't know if, but these two in particular need to be there in order to ensure that something is accurate. So that's what this section is all about. As you can tell, we didn't do any calculations here. So just remember that. So have a little bit on your study sheet on accuracy, short and sweet, don't overdo it. But just remember, maybe I should guide you because this one is hard to narrow down. So I'll tell you this. If you flip back to page 2, I would say, to be honest, I'll put I'll make me circle in orange what I really want you. So maybe you use whatever you have available. The definition of accuracy. The definition of accuracy and this, but not, obviously it should take up a lot less space than that. If you have that for today, I think you're good. Okay, if you have this, but make sure it's small, guys. Like, don't make it use up too much space. Nice and compact. Okay. So if you have this circled in things, you're good for this section. All right, let's move on. So now we're going to go into precision and uncertainty. So accuracy is put aside for a bit. So here you have to, if you're not awake yet, now you need to wake up, right? So now I'm gonna give you various examples on precision and uncertainty. Here we go. Precision refers to the smallest increment on a measuring device. Another way of saying what I just said is that precision is the smallest amount by which a measuring device can go up or down by. I would say, if you can summarize, to be honest, for me personally, the first statement here would be enough. That's me. That I would know what, if you just gave me that first statement, I'd be fine. But maybe some of you need that other way of saying, but remember, don't take up too much space, okay? And maybe this you will have to figure this out later when you prepare for the exam, right? Then you're gonna try to slice and dice and do whatever. Every measuring device, no matter how precise, will have a limitation. Precision essentially states that limitation. Precision essentially states what the limitation is of the device. So it doesn't matter if you go to NASA and go and look at their devices that they use to measure something, it will have a limitation. Like it can only go so precise, but at some point it's guessing a little bit. Okay, it's rounding up or down. Unfortunately, we don't see that on the measuring devices, that it's rounding up or down. Next, uncertainty, which is directly related to precision. What is uncertainty? It's not what you know in the English language, uncertainty. I'm a little uncertain whether or not I'm going to come to Mr. Dirkson's class tomorrow, right? It's not that. Uncertainty in this unit means something specific. Due to the fact that every measuring device has a limitation, so that we just talked about it up here, there's always some uncertainty. All measurements have the potential to be off. All measurements have the potential to be off, regardless of the precision of the measuring device. At some point, you have to round up or down. This is called the margin of error. So I'll tell you this, that uncertainty is also known as the margin of error. Here's another one I want you to know. Mathematically, uncertainty is always half of what the precision is. Okay? Uncertainty, then mathematically in this unit, okay, only in this unit, is precision divided by 2. Okay, so this is not on a formula sheet, so you're going to have to add this to your study sheet for sure. And notice what it says, usually stated with a plus or minus ahead of it. I'll give you a small example here. Example. If the precision is equal to 4 degrees Fahrenheit, let's say. If you determine that the precision is 4 degrees Fahrenheit, then the uncertainty in this case would be 4 Fahrenheit divided by 2. So we always divide it in half. So uncertainty is equal to 2 degrees Fahrenheit. And notice what we do normally. We go plus or minus in front of it, like meaning you could be off on the up by 2 degrees or below by 2 degrees. So we go plus or minus. This is the uncertainty. So if you know your precision, divide it by 2, you get your uncertainty every single time. So the trickiest part is going to be finding the precision. Because once you have the precision, just divide the precision in half, you've got your uncertainty. Okay? Okay, let's do some examples here. And then later I might use my gadgets to help you out. You are expected to state the precision and uncertainty given the following. You can have a picture or a diagram. You can be given with just an actual number, like an actual measurement. Or you could be given something in words. And you're supposed to figure out the precision and uncertainty every single time. Okay? So let's start with our picture or diagram. The precision, when you look at this, from a marking to another marking, that would be the smallest amount that we can go up by. So from 10 to 20, how much did we go up by? 10, right? And to go to 30 is another 10. And to go to 40 is another 10. So now you've determined your precision right there, just by observing what the pattern is from one, listening carefully, right? From one marking to another marking. Don't be thinking from a number to another number. I'll explain in other examples, but it's from marking to marking. So 10, what? What are our units here? Milliliters, so you put that down. That is the precision of this device. And therefore, what's my uncertainty? You guessed it, it's 10 divided by 2, so it's 5 mLs. I'll tell you a little secret. If you forget the plus or minus here, you're going to be all right, okay? But technically, when it's uncertainty, we go plus or minus 5. So what we're saying is, regardless of what, like if you fill this up with liquid, whatever measurement you read, you could be off by plus or minus 5 mLs. So if you measure, let's say, if you measure 10 milliliters, you could actually have 15 or 5 in there. I know it's a little extreme. I know you're like, that doesn't make any sense, because I can tell by looking at this that it's 10. It doesn't matter. We are going to apply the standard uncertainty of plus or minus 5 every time. So that's it for this one. I will just define this a little bit. Precision is 10 milliliters because the smallest increment is 10 milliliters. Can you, hold on, I'm going to put it further up. Some of you probably can't see because someone's head is blocking that, right? Precision is 10 milliliters because the smallest increment is 10. And I'll just say that. I'll just leave it at that. I'm not kidding you. Sometimes this is it on an exam. They give you a picture of something. All you have to do is state the precision and the uncertainty. Or sometimes, even better, all you have to do is precision. That's it. Sometimes they just ask for the uncertainty. But guess what? If you want the uncertainty, what do you need to know first? You need to know the precision, right? So you can't just skip straight to the uncertainty. So let the marks guide you on the exam, right? 1 mark each usually. That's what they do. Okay, this one is the trickier one. This actual measurement here. What's the precision here? We have no idea what device was used, right? For all we know is they may have used a ruler. They may have used measuring tape. They may have used, where's my other device? The one I used for the Apple. Caliper. Oh, here. They may have used this. We don't know. We don't know what they actually used. So you kind of have to just go by the numbers. Okay? So you focus in on the last number. So in this case, there are 2 decimals. You focus in on that one. Precision is found here. You focus in on the last digit there. So watch what you're going to say. Precision is going to be 0.01 centimeters. Just write that down for now. Say what? I thought it was a 7, Mr. Dirksen. You said the last one. No. That's where it's found. So what's happening here is, write this down with me. So imagine your screen is showing you this. Let's imagine this is a digital device. If this thing had been a little longer, right, whatever we're measuring, what would it have been? Just a little longer. It would have been 28, correct?
Yeah.
7 to 8. If this had been a little shorter, yes. Do you know how much you're going to go up by every time? Plus 0.01. Plus 0.01. And therein lies our precision of 0.01. Let me zoom into that because some of you are probably squinting there. Is that gooder? I had a student that used to say that, and I just chuckled every time I said, it's better. That's what I said, it's gooder. Anyways, right, so that's why I got the precision, right, because of this, okay? So what's my uncertainty? You take your precision, 0.01, and you divide it by 2. What do you get? Use your calculator if you're not sure, because some students guess, and I don't want this to be a guessing game. 0.005. Yes.
Minus 5 minus 3 times 10.
So the uncertainty is 0.005 centimeters. So there's your uncertainty. There's your precision. Please do not do this. I don't need this part here. This is just for you to figure out why the precision was 0.01. It turns out that unless I tell you otherwise, it's always going to be something 1. It's going to be 0.00001, like however many decimals there are, but it's going to have a 1 there unless I tell you otherwise. Okay? Keep going. Words. A ruler marked in half-inch increments. Actually, to me, this is the easiest one. Marked in half-inch increments. It's telling you, right? It tells you that it goes up by half an inch. Right? It tells you that. So what's the precision? Yeah, 0.5 inches. You can do fractions. Uh-oh, I don't like fractions, Mr. Dirksen. Okay, here we go. You're okay doing that. You decide. Half an inch as a fraction, 0.5 as a decimal. That's fine. What's the uncertainty? Divided by 2. Do we want to take the fraction divided by 2 or the decimal divided by 2? I like the decimal more. There we go. And that is 0.25. And we are in, that's the one thing this unit is really picky about, is the units. There's always going to be a unit there because it's precision measurement, right? So inches, centimeters, millimeters, milliliters, ounces, you name it. Are you familiar with this? If I were to go half an inch, would you know that that's inches? 2 markings. Sometimes the province has done that. 1 is foot, 2 is inches, right? So remember that. And if you don't know, just copy what they do. If they have 2 like this, you just put 2, right? And then you're good to go. All right, let's do another one. Fun, eh? You know. You're all going to come back charged up tomorrow. All right. Picture or diagram. So let's do this exact same thing again. What's the precision on this one? Number 1 mistake, 100 to 200, that's 100, so it must be 100, correct? No. From marking to marking. So let's do some patterning here. This should be 150, correct? Because it's halfway. So fill that in. So that means that we went up by 50. And so that means that we're going up by 50 again. Oops, why did I put degrees there? Not sure why. And you can also from there just say, hey, how about to go down here? This should be 50, correct? I would go minus 50 to go down. It doesn't matter. The fact still remains that from one marking to the other, it's 50. Okay? Precision is 50 mLs. That's it. Therefore, my uncertainty, 50 divided by 2, that's 25 milliliters. Plus or minus, that's the official way of answering that one. Okay? Which one is more precise between this one and the one we just did before? Which one is more precise, the 50 or the 10? The answer is the 10. This device here would be more precise because it has smaller increments. Okay? Okay, let's do another one. 6 feet 2 inches. What's the precision here?
2 inches.
It's not 2 inches, but it's... What does it go up or down by? If this person was a little taller, we'd go 6, 3. And if it's a little shorter, 6, 1, so it's 1 inch. Yeah, so sorry, I'm gonna do this one more time because some of us need a reminder, right? A little shorter would be 6 foot 3 inches. A little shorter would be 6 feet 1 inch. So it's 1 inch increment. I try so hard to make you understand, and sometimes I overdo it. Okay, so my goal is for you to have a pretty good understanding by the end of this unit, and you can just ace these questions. Because to be honest, this is the unit where I see a lot of blanks, and I'm always like, just put something down. Chances are you're going to get it right. Okay, so uncertainty is just half of your precision. So if you get your precision wrong, you will lose the mark there, but you could still get marks for the uncertainty. So if you said precision is 2 inches, you would have 1 inch here, right? But that's okay. Next, a measuring tape with markings of a 1/4 inch. I'm just going to go 1/4 inch. What is that as a decimal? Just do it that way. Because it says markings of 1/4 inch. Increments of 1/4 inch. All of them mean the same thing. What's half of 1/4? Don't round. Yeah. 0.125 of an inch, plus or minus. Okay. So that's how it goes. That is how it goes. One more, and then I'll let you fly solo for a bit. A lot of these pictures are from stuff that I found at home, okay? So that's what they, honestly, that's what they do. It seems like they just walk around and just take a picture and put it on the exam, okay? What is the precision here? What do you think is the precision here? So I would say this, focus on 2 numbers, right? So I will focus on this one and this one. And I'm going to try to pattern this. So there's 1, 2, 3, 4, 5 gaps, right? What do you think they should go up by for you to get from 10 to 20? 2, right? 2, 2, 2, 2, Pizza Hotline, right?
Oh my God, yeah. Just think of the little jingles that they do in every commercial.
There you go. So my precision is what? 2. It's not 10, right?
Yeah.
Because 10 to 20, yeah? So precision is 2 what? 2 what? Look at the diagram.
2 minutes.
Minutes, yes. So my uncertainty is 2 divided by 2. So my uncertainty is going to be plus or minus 1 minute. I know it's weird, but you just need to go with it, right? You just need to go with it. That's all I've got for you here. I want to show you a shortcut, but last time I did the shortcut, it actually backfired, so I'm going to wait a little bit till you wrap your head around it, and then I'll tell you. Okay, what is the precision here? We focus on that last number. Is my precision 8? Something 1, right? So we're going to go precision. You know what? I'm going to leave some space for the diagram in case you need to wrap your head around it. But precision is start with a decimal. Everything else doesn't matter here. So 0 point. How many decimals are there? 3, right? So 1, 2, and on the third, you slap that 1 in there. Exactly. Yeah. 3 decimals, right? Third decimal. Okay? Therefore, this is also on the third decimal. So what's my uncertainty? You guessed it. Just divide that by 2. as weird, as small of a number as you get, it doesn't matter, okay? And some of you are going to see a pattern. It's basically another 0 in there, and then with a 5 at the end, if it's 1, right? We are in millimeters. I forgot the plus or minus. So that's my uncertainty there, okay? How did I come up with the 1? Some of you are going to say, no, I'm not copying this, I'm done here. I get it. If this had been a little longer, 359, right? A little shorter. So I'm going, this is plus 0.001 plus 0.001. Okay? So that's why that is. Next, measuring cup marked in 125 ml increments, no problem. I'm going to say that my precision is 125 ml. My uncertainty is 125 divided by 2. 125 divided by 2 is 62.5 ml. This is just the standard in this unit. That's how we do it. So everything you ever see has an uncertainty. The cookie pack at the store that says it's 350 grams, it's actually 350 plus or minus something. The Coke can that says 355 ml, it's actually plus or minus something, right? There's a bit of an uncertainty there. So your Coke can doesn't always have 355, just to be honest there. It's not going to be 355 every time. Okay, you're going to try the best of your ability. I want you to do, we're going to go to pages 8. Look at that, I have a whole bunch of goodies there for you. 8 to 14. Yeah, it's a whack load of pages, I know. You're going to do a bunch before the bell rings. Full disclaimer, there are a couple that are not fair. There are a couple that you're going to come across those. They're not fair because, and I wasn't thinking when I took the picture, but it was a measuring device, but we wouldn't use that because it's not quite consistent. Just try your best. Most of them work. And I'll put the key up as you work, okay? So that's all today. Precision, uncertainty for all of these. Precision, uncertainty, every single time. If you can do that, you've accomplished what I wanted to accomplish today. You learned precision, uncertainty, and accuracy. That was the first part. Thank you, guys.